Hello, I would like to present you presentation matrix stochastic game with Q-learning for multi-agent systems. Authors are Petro Kravets, Vasil Litvin, Igor Dobrotvor, Oleg Sechenko, Victoria Vysotskaya, and Anatoly Sechenko. A model of matrix stochastic game for decision-making in condition of asymptoticity is developed. A Q-learning method is proposed for solving a stochastic game with a priori unknown payoff matrices. The formulation of the game problem is performed. The Markov recurrent method and the algorithm for its solution are described. The result of computer simulation of stochastic game with Q-learning are obtained and analyzed. In this paper, there are a range of change in the parameters of the game Q method are experimentally established to ensure their convergence to one of the Nash equilibrium points. As the value of the current Wien discounting parameters increases, the variance of current Wien is reduced, and the order of change for the learning step decreases, and the convergence rate of the game Q methods increases. The stochastic game of agents in a stationary environment is defined by a such tuple, where I is the set of players' numbers. A is a set of discrete actions, pure strategies of the ith player. V is the reward function of the ith player, and A equal AI is the set of combined players' actions. Ri is the set of values winning of the I players. The stationary game environment is given by the set of payoff matrices, such where V equal E constant is the mathematical expectation of random winnings. The choice of pure strategies is based on the random distribution based on the mixed strategy. It's this strategy. The game moves of agent are estimated by the discount total winnings functions. It is represented here, where gamma is belongs to range 0, 1, is discount options. A partial case is the average winnings. The calculation of the functions can be performed in the recursive form. It's given here. To evaluate V during the game, we use the method of iterative Q-learning, which is represented here, where A belongs to A and alpha is the learning parameter. V is the value of winning functions in the direction of optimal collective solution. Last method can be used to solve the game of one agent with nature as a partial case of an agent stochastic game. It's represented here when V is maximal of Q. Multi-agent play is optimal for Pareto if there is no common strategy of players which allows to improve the winnings of all players. Pareto optimal mixed strategies, which is represented here, can obtain by maximization the convolutional of concave up gain functions, which is represented here. Choosing of pure strategies is carried out of the basis of random distribution based on mixed strategies, which are represented here, where V is a real random number with a uniform distribution. The convergence of the method is estimated by the error of the condition of additional non-rigidity weighted by mixed strategies. A qualitative indicator of the convergence of the game is the growth of the functions of discounted total winnings or the function of winnings average over the number of players, which are represented here. Stochastic game solution solving algorithm. Step 1. Set the parameters of the game. L is number of players, N is the number of strategies of each player, and A is set of discrete actions, pure strategies of player. V is matrix of winners of deterministic game. Initial time t is equal 0. Initial values of stochastic game payoff matrices are represented here, where epsilon is in range from 0 to 1, is a small positive value, and the value of the payout discount parameters is the initial value of the parameter alpha. K is the order of learning speed of method 1. T is greater than 0 is temperature parameter of the system. Calculate the values of mixed strategies based on current estimate of payout matrix according to equation 2. Step number 3. Make a random selection of agents based on strategies in accordance P according to equation 3. Step number 4. Obtain current agent winnings according to equation 1. It is given here. Step number 5. Calculate the parameter of the learning step alpha according to 5 is given here. 6. Modify the payoff matrices according to 6, according to this equation. Step number 7. Calculate the error of fulfillment of the condition of additional non-rigidity delta 7 and the value of functions of average gains. Equation number 8. Step number 8. If this is true, then specify t is t equal t plus 1 and go to the step 2. Step 9. Output the calculated values of PO matrices and strategies here and we can stop our algorithm. And some conclusions. Performed research confirms the iterative method of Q-learning with restriction of its parameter provides a solution to the stochastic game in conditions of payout matrices uncertainty, and it can be used to support the collective decision making. The disadvantage of stochastic play is the low with a degree order rate of convergence due to the process of training players in conditions of a priori uncertainty. Then positive point is the possibility of parallelizing the stochastic game with use of powerful computing tools to accelerate the process of its convergence for practical applications. New research results in this direction can be expected from the introduction of other criteria to the formation of player payments and other methods of teaching stochastic play, for example, using artificial intelligence methods. Thank you for your attention.